All right, well, I'm going to make a start and like to wish everyone who's joining us good morning if you're on my side of the world, or good afternoon if you're on the eastern side of the world, and I hope I'm not disturbing your night if you're somewhere perhaps in South America or somewhere like that. So good to have everyone with me. This is the final session in this series of MRDCL Masterclasses that we've been running the last 5 months, been running one a month. And in today's session, we're going to be looking at building some solutions to common time-consuming tasks. And I've got 4 things to talk about today. They're sort of connected, but they're also jumping around at different sort of concepts and parts of MRDCL. The first thing we're going to look at is actually building a solution to picking up tracking data, and we're going to build that solution from the ground up. The second thing we're going to look at is quite a quick session, but just sort of some tips and some discussion on handling perhaps big projects or big tracking studies. So again, a little bit of emphasis there on tracking studies. And then in the third example today, we're going to be looking at picking up data from an external source, so such as Excel, CSV files or something like that. And finally, we're going to be looking at a more complex solution and looking at how perhaps we can add bits to that, or perhaps improve that in some way to make it do a little bit more than it does already. So when that'll become a bit more apparent when I get to that particular example. But really today the focus is on building solutions and trying to do some things that make life easier for you and shorten the time that you spend on handling sort of problems that you might have. So there's no PowerPoint today. That was just an introductory slide. We're going to get straight into running some code today and looking at practical problems that we're going to try and solve. And the first thing I'm going to look at today is looking at picking up data from tracking studies. Now, this is something that many people encounter, and it's something that's very easy to find time consuming, because we all know what happens with the tracking study. It starts as something that's never going to change, but very quickly researchers or clients perhaps change that, and suddenly you find that questions are coming and disappearing from wave to wave. They're slightly different, those questions sometimes. The data locations that you find the data in have changed. Filters might even change. All sorts of things happen. Even odd codes might change round, either through intentionally or perhaps even by mistakes in printing questionnaires, all sorts of reasons. So we're going to put our toe in the water on that today and just have a look at some of the practicalities of picking up tracking data. And for this example today, I want to just introduce you to what we've got here. We've got 4 data files which are called Q4 2019, Q1 2020, Q2 2020, and Q3. So we've got a year's data basically here in 4 files. Actually, I think each file only carries in it about 10 records, so it's only for example purposes, but it'll be fine for illustrative purposes here. And the problem we've got with that is that the data within each of those changes each time. And what I've got ready prepared here is a spreadsheet that contains the changes for each of those files, the differences. So what we have here is a spreadsheet that I've prepared in advance here. And you can see all that I'm doing, or the main thing that I'm doing in here is specifying the variable, giving it a title, saying what type of question it is, single or multi, telling the worksheet telling the this worksheet what worksheet the texts are. So for example, the text for gender are in a sheet called gender. The text for region, let's open region, there they are in a sheet called region, and the text for these rating scales are in a worksheet called rating. And they're the text, so 1, 2, 3, 4, 5, very good to very poor. So nothing terribly unusual about that, all fairly easy to understand. If you didn't want your text in a worksheet here, you might have an insert file here that pulls in the text. So you might have a file called gender.stp, and we would then be able to read gender.stp into here, and it would feed those in. But we can look at the solution we're going to come up with in just a moment in a bit more detail. But this is the core of the problem that we encounter on tracking studies. And I'm not saying it can't be more complicated than that. It can be that codes change. So for example, gender might be codes 1 and 2 at one wave, and then might be the other way around, 2 and 1 at another wave. But we're not going to get into that depth today. Let's look at perhaps the biggest problem, or the first thing that we can cover by building a practical solution, and that's the issue of the data. So what this is telling me is that at data 194, in other words, Q4 in 2019, this question was on field 4, 5, 6, 7, 8, 9, and that one was 0 because it didn't exist. At Q1 2020, it was almost, in fact, it was identical, exactly the same. But then when we get to Q2 2020, this has moved a column to 5, this has moved to 6, this has jumped to 8, that's in 9, 10, 11, and that question still doesn't exist. But when we get to the third quarter of 2020, that question's disappeared because there's 0 there, and we've got a new question on the end now which has suddenly appeared, which is in data location 13. And this is something that happens quite regularly on tracking studies, and this can become quite cumbersome to handle, not in terms of complexity, but just time consuming to actually specify all these data locations. And I have seen people deal with this problem by recoding all the back data to the current layout. So there might be a recode that moves all the data here from the previous wave into the new location. So what was 11 gets moved into 12. I really don't like that solution, and my reasons are quite simple, that it's quite hard to check that, and if you make a mistake, that error will probably get perpetuated for quite some time. Whereas if something goes wrong here, it's much more easy to see and spot, and it wouldn't get perpetuated forevermore. It would, if you did put that in 13 when it should be 11 by mistake, yes, that data would be wrong for one wave, but it wouldn't be carried forward. It'll just be that wave's the data that be wrong, which I'm not saying is good, but it's probably preferable from perpetuating a mistake in data forevermore. And I have known people to spot errors in data a sort of year after they've done recoding on data. So what we've got here then is something that's very easy to understand, easy to fill, with a little bit of knowledge of very basic programming, or even using things like VLOOKUP that people, there's functions in Excel. It can often be quite a simple way of populating this directly from a spreadsheet containing these data locations that may have come from another program. So let's say you use another program to collect your data, or have used another program. Many of those will be able to give you a spreadsheet so that you know what fields each question is in at the current wave, and with some clever VLOOKUP work or some VBA programming, or perhaps other tools in Excel. I don't know all the tools in Excel, I have to confess. You might be able to get that in there automatically, so that matching on the word gender here would automatically drop that in there for you without you doing any work. So any tools like that that can improve automation have got to be good, and got to be a very practical way of working. And it's worth mentioning as well, in the next release of MRDCL, you will be able to read data from CSV files with a heading. So if a CSV file has got gender in a field, you'll be able to pick it up directly from that, without actually doing any of this at all. So there are some other ways of approaching this in future versions, and that's coming out in the next couple of months. So let's look at this problem then. Now I want to write some script that can handle this. Now the tool I'm going to use for most of this is going to be the technique called EPS, which I know we've done other videos on. We've done, in fact, 2 of our first masterclass in this session looked at handling a complex solution in EPS. This one I think is less complex, perhaps more practical and more perhaps in the grasp of people who haven't got as far as doing really advanced EPS work, whereas the first two sessions we ran, especially on EPS, were much more about getting ideas and constructing approaches and tools and construction, rather than perhaps the practicality that we've got here, although we did do a practical example in that. So that's the first spreadsheet to look at. Now the other spreadsheet to look at is this file here called datafiles.csv. Excuse me. And this file here, if I can just expand this column, this has got 3 columns in it. It's got a column called data file, which is just the list of my 4 data files that we saw just now. Some text here so that we can use that in a table, and the identifier to say what makes, or an identifier to say that we're going to call quarter 4 19 194, quarter 1 20 201, and so on. That's just my own coding, but effectively I'm assigning a value here. Now, the first thing I want to do is to actually pick this data up and use it. And this is a very good approach on tracking studies. Actually, regardless of EPS, this is a really good tool to use. So let's start by worrying about that. And I'm going to actually type this in as I go along. I have got a backup file in case I make a mistake. So we're going to call it demo.stp, if I can type that correctly. And I'm now in an empty file called demo.stp, and I'm going to start writing my script for this project. Now, the first thing I'm going to do is that rather than type in a list of files here, I'm going to say that my files are in that CSV file that you just saw, data.csv. In other words, I want MRDCL to read the list of files from this spreadsheet. Now, to do that, MRDCL will want that field to be headed data file. This field here is irrelevant, but that file there, of course, is important, the value it's going to assign to it. So I'm going to read it directly from that file. I'm going to start data. Now, the first thing I'm going to do is I'm going to define, if I can type it correctly, a dummy variable called iWave, and I'm going to call that Wave ID. So what I've done is that variable name there matches, as you will see, the heading there. And when you use this technique to read data, C equals data.csv, that will make MRDCL automatically assign the value of iWave for that particular respondent. So any record coming from the quarter 4 2019 data will automatically get a value in iWave of 194. Any record from this file will get a value of 201, 202, and 203. So automatically I'm getting a value assigned. And indeed, you can assign as many fields as you want here. You could assign year in here if you like as 2019, 2020. That would be equally valid as well. And I could have a variable called year, which I dummy defined in the same way. Let's do it. It doesn't do any harm. So that going forward, I could easily analyze my data by the year 2019 and 2020, although of course I could group the quarters together to achieve the same effect. All right, so that's the first thing that I've done here. So I'm going to read first of all from datafiles.csv, because I actually want to build a variable that comes from this CSV file as well, so that I can use it in my analysis, because I don't want to do this work again. So the first thing I'm going to do is open up this data file here, and I'm going to say star data files bracket CSV equals data files. Oh, it's data underscore files. And I could put the .csv on the end, it doesn't matter, but that's going to put into a data file, a data statement rather, these cells here. So it's rather like typing all of that into a data statement with 20 cells in it for 5 rows, sorry, yes, 20 cells, 5 rows by 4 columns. All right, so let's proceed with this now. So what I'm going to do now is I'm going to test to see how many cells data files has. I know we know it's got 20, but of course at the next wave there'll be another wave added and it will increase up to 24 cells because there'll be another row of 4 columns in there. So now I know that, I can say that ds$wave is $iwave/. And now I can loop round my CSV file, and I'm saying I want to do a 5:cells:4. Why am I starting at 5? Well, the data statement reads across. So where I am now is 1, that's 2, that's 3, that's 4. I also don't want to use the header row. I want to start here. So I want cell 5 and I want to go to the 20th cell in this spreadsheet. But of course at next wave it'll still start at 5, but I would want to go to the 24th cell. So I'm making that an automatic feature, if you like. All right, so I'm going to say set wave equals data files.a+. So the wave number is set here, not in the 5th cell, but in the one that's 2 to the right of that. So that's A+2. I could have said 7 to cells in steps of 4 there and perhaps save myself a little bit of work. Pull in that wave number because that's what I want. End A, and I'm going to put an E on the end in case any record hasn't got a wave code for some reason, or there's a data file that hasn't got a wave code. And indeed, that would be a good check. If I forget to update my data files or something like that, or put an invalid number in there, that would be quite a good check. So let's now carry on. I want to pick up those texts. So I'm going to go again around the loop of data files in steps of 4. And I should just say, just for anyone I've confused here, this name here doesn't have to match that name there. They are different things. So that's the name of the file. Sorry, I'm saying that name there. So that's the name of the file, and that's a name I'm giving the data statement. I could have called it equally XYZ and then referred to it as XYZ down here, but I haven't. Okay, so we're now going to loop round this again, and we want to say start, and I want to pull in data files .a+, and the text is that column there. So I want the text from A+1, I want a semicolon, I want end A, and of course I've got a not stated, which I might put a Z on, and wave. So now I've picked up the wave, and I could actually do a test on that. Let's do that, and let's just check that what I've done so far is working fine. All right, so let's save it and run it. All right, I have now managed to get out a table with my waves in it, and so I have got my records coming out now. 10 records for the first quarter, 8 for the second, 12, and then 8. Let's move on to the next task, which is now to start to read the data manager file that I've got here. So here's the data manager that's got all these different fields in there with the texts. So I'm going to first of all open up that data manager. I'm going to do that at the top here. It's a good idea to do it at the top. It doesn't particularly matter where you do it as long as you've got it open in time. So I'm going to open up, and I'll try to spell it right this time. Yep, and it's good practice to always close these at the end. So at the very end of this run here, I'm going to close this. And if you've been to the previous masterclasses, you'll understand that syntax of opening up. I'm not going to spend too much time looking at EPS syntax here. I'll describe what I'm doing as I go along, but we have covered all the basics in previous sessions. All right, so the next thing to do is to actually pick up the variable. So let's put a comment in here, pick up the variables. And to do that, I'm going to loop round the waves and pick up the data for each of these columns one at a time. So I'm going to pick up the data for the first wave, then the second wave, then the third wave, and then the fourth wave. Now, you might say that'll be a lot of code, and indeed it will multiply out the code. The other way of doing it would be to pick up all of the definitions for one question at a time. On a big project, that will probably be slightly more efficient, but it won't be desperately inefficient here, because if you think about it in processing, each record will only go through one of the blocks of code. So a record from this quarter will only go through that block of code, a record from that quarter will only go through that block of code, and so on. So it isn't particularly inefficient doing that. And the fact that you're redefining the same variables just from different columns won't load the IDF size at all. So although it appears like you've got a lot of script there and you're giving it a lot more processing to do, it actually will have pretty minimal impact on your run times, because in execution, records are only going through one of the four data layouts or data formats, data maps. And when it comes to the IDF, it's going to be the same size, because each variable only exists once for each wave. So I'm going to now loop through the cells again. So this time I'm hopefully going to get it correct. Cells in steps of 4. So same principle as before. And I'm going to set the wave just as I did before here. So that's data files .a+2. I could have copied that from above. It's the same principle. It might be a good idea to close this loop so we don't forget what we're doing. And in here, I can say, unless $I wave is wave. So unless it's the right wave, I don't want them to go through this block of code. So I'm going to send them to W wave. W wave. So they're going to skip round this block of code and only go through it for the current wave that they happen to be on. So let's have a look at that just to see what it looks like. Only going to compile that. And so what I've got now, if I scroll down, you can see I've got blocks of code for each of the different waves. And in here now, I'm going to put all the definitions for the first wave. In here, the definitions for the second, third, and fourth. So we're making a bit better progress than I was before. All right, so let's carry on. And now we want to start picking up the questions in the data manager worksheet. So let's go looping around that. So we're going to loop round a loop called DB1. We're using the workbook DBXLS, which is data manager.xlsx. And the worksheet we want to work from is this worksheet here called questionnaire. So let's try and type that correctly. Again, I find it good practice to close that loop because it's so easy to forget it otherwise. So that's written that loop. Now the first thing I want to pick up is the wave number here. The column number here for that particular wave. So that comes in the field data _194 in this particular case. So I want to say set col is db1.data _wave. So you'll note what I've done here is I've made the wave numbers consistent with the headings here. So when it's 194, I want to read from data 194. When it's 201, I want to read from data _201. So that's where I'm reading from data _ whatever wave it is we're processing at that time. And that will pick up the column number. All right, so let's say skip 99 on col equal to 0. So the first thing I want to do is, if that column is 0, I don't want to pick anything up because it just didn't exist at that wave. So this question didn't exist for the first 3 waves, and this question didn't exist at the 4th wave. So I'm going to skip round it if the column number is equal to 0. And it is important you fill that with a 0. If it's blank, it would have a problem. You could pick it up still as being the field as being empty, but that would be different syntax. But I'm actually putting a 0 in there. I think it's a bit more readable that way. All right, now I can define my variables. So I can say define db1.type. So what does that mean? So that's going to pull in the type of variable I want here. They're all singles in this case, but if I had multis or integers, I could behave differently. And I want to define db1 dot, and there's my question ID in this column here. So we want ques underscore ID. I just checked, I called it that, ques underscore ID. And it comes from col. Now, what column does it come from? So what codes does it have? Well, the codes are hidden down the worksheet here in gender, region, and in this case, rating. So these are the codes here. So I'm going to need to loop round these sheets to get the codes. Now, as I said in my introduction, you could just make this an insert file and have a file called gender.stp, and then you could say in here star insert db1 dot texts .stp or something like that, and that would be absolutely fine if you put your texts in gender.stp, region.stp, and rating.stp. I haven't done that. I've got my codes and texts in a spreadsheet, just like the definitions before it. So I'm going to need to start another loop here. So I'm going to say star db loop db2 equals dbxls, so the same workbook, but the worksheet I want to loop around is db1 dot texts. So that's the one that's going to tell me what worksheet I need to loop around, and I want a second square bracket there, which can sometimes look a bit strange, but that's going to do me fine. So then I'm going to say set code equals db2.code. So that's going to pick up the code in here. Going to pick up the code 1 and then the code 2, which means that having got that, sorry, I've done that wrong, equals db2.code. So that's picked that up, and then that means I can use the code here. Again, you could give it a different name. You could call it my code if you like, and we could put my code in there and give it a different name. Some people prefer to have the same names or similar names, and others prefer to have completely different names to avoid confusion. DB end, close, and e comma. So let's have a look and see how we're doing now, see whether we're getting out what we want. Seems to be compiling, and we can look at now, we see we've got down here, we've got ds.agenda is 1, 2, and E, region is 1, 2, and E, 1, 2, 3, 4, 5 E. Yep, so it looks as though that's all working absolutely fine. You might decide that you think it would look tidier if it's all on the same line. It doesn't slow down MRDCL at all doing that. So some people like to put that all on one line just so it reads a bit easier when it comes out to the listing file. It really doesn't matter. Now we can pick up the labels, so we can just go around that loop again. So we can say star db loop again, db2 equals dbxls db1 dot text square bracket, and in here we want to put in db2 dot text. It's just text, I think. Let me just check that. Yes, the column's headed text here. Let's go back to the right file with a semicolon, dbn, db2, and we need a not stated on the end because we've allowed for not stated. And finally, we want a title to come in here, and that does come back from the db1 worksheet. Let's go back up to the questionnaire worksheet, and the title is in question underscore title. So let's put in question underscore title, quote, comma, and hopefully now we've done all of our variable building. Let's just quickly close that. and it looks as though it's working fine. So now we've got our definitions, we've got all of our texts coming through and our titles, of course, and we've now got a project that's going to pick up the data from those different locations regardless of where they are. So we've done now, if you like, the hard bit. We've now picked up our data. I perhaps should have looked at that in a little bit more detail. So if we look at the variable gender, for example, the first time there it's picking it up from $4, the next time from $4, the next time from $5, and the last time from $5. So it looks as though it's working. If we look at question 5, we find that only gets picked up from 13, and it's only the last time round the loop. So it's only for the final wave that we're picking that up. Okay, so we've now got the basics of everything working. We can take this one step further if we want to. We could also automate our tables from this if we wanted to. Let's do that. Let's just do a complete job here. So we would probably want to do something like use ANR and BSC for this. And we want to use ANR because we're relying on everybody being within a wave. Otherwise, it'll just base everything on total here. So I'm using ANR. Set t equal to 0. Oh, so we've already done set t equal to 0. Let's take that out. And we can just loop round these tables one more time. And we can say table hash plus t is $db. Whoops, I've managed to open up a different screen here. db1 dot ques ID star $wave. So we could analyze each of our questions now. And you might want to do something different in here for singles and integers. I've taken a bit of a shortcut here, but that's perhaps for something for you to try afterwards, because you'll be getting all these scripts. I managed to type that wrongly. All right, I think I've done what I need to do here. Let's run it. And we seem to have 8 tables. So there's my wave table that I did originally. And now we've got each of our questions analyzed by wave, even though the data locations are different for every wave. So that all looks as though it's working pretty well. And I'm fairly confident that those tables are correct, even though I had a bit of a bad start when I was doing this script. So there we are. We've had a practical solution there for picking up data from a tracking study. You can obviously extend that to do more things, but hopefully that's a useful script as a starting template if you actually want to use what we've done here. And I'm going to quit that file. Again, I've managed to open the file twice. All right, so that's the first example we're going to look at today. The second one is a much shorter one, and it's really to do with making things temporary and using IDFs properly. And again, it applies to tracking studies, I think. I have seen the scenario where people are running tracking studies, and what they want perhaps is a run of tables on the last year's data, a set of tables for the last quarter, and perhaps a table for the last month, something like that. So they do 3 different STPs they run. Now, really, that should all be contained in one STP file. You shouldn't have multiple STP files unless the analyses are really very, very different. Perhaps the tables you might have in separate files, but certainly only one data stage. You really don't want to be having differences in 3 or 4 different files, because if you do that, you've got to make changes 3 or 4 times. So let's look at a run here, and it is a false run. It is just a big run that's got 200 variables in it of 9,999 responses. By the way, that's being up to 30,000 in the next release that's coming out in a few weeks' time. And we've also here got 400 variables that are picking up the same thing called Q1 to Q400. So really all I've made here is like a dummy run that's doing a lot of tables that are quite big by themselves. which are not very interesting tables, but we're looking here at run times, and we've got quite a lot of data as well. So let's just run this, and I want to make some observations as this runs. So you can see now it's reading up quite a lot of records. I think it runs to about 20,000 records this run. Yes, it does. So, and it's now going to do 8 passes on the data. And this will take a little while because it's processing some really big variables here. Remember, I've got those dummy definitions. I think it was 40 variables with 9,999 responses in. So this run's taking a little while to run, but I'm showing you this for a very good reason. And now it's producing 400 pages of output. So if we look at the log file here, let's just expand this and have a look at what it took. So if we go to the top of this file, if I can do that, I'm trying to scroll up. Here we go. It started at my time 9:41 exactly, and it ran almost a minute. Took almost a minute to run that. It seemed longer when it was running, didn't it? So it took a minute to run, and one of the problems here was that this wasn't made temporary. We made lots of variables that really weren't very necessary, so that wasted quite a bit of time because the IDF held 200 variables of 9,999 responses. So the first lesson here is if you can make any variables temporary, they will start to have an impact. And let's see how much time that saves. So we were just under a minute before, and let's see how long it takes now. Running this on a network, so it will be a bit slow, and perhaps I was running on my hard drive. Again, most of the time here is in doing the passes on the tables. Reading the data was fairly quick. And it's just going to the last pass now before it makes the 400 pages. Okay, so that ended at 43:45, and so I probably got it down by about 5 to 10 seconds there, a bit less than 10 seconds, so about 5 or 6 seconds quicker. So by making it temporary, I made it a bit quicker. I sped it up by about 10-15%, I suppose, 15%, something like that. That helps. Of course, the bigger the project, the more variables there are, the more cluttered the IDF gets, the more time you're going to save. And I wouldn't say it's exponential, but it's not a straight line. It's not just a straight line, the degradation, or the degradation should be downward, I suppose. It will gradually, it will eat up more and more resources as you go. Now, really, the way that I should have handled this was to split this run here, so that once I've run the run, and if you look at run 2 here, this is the same run again, but it's just a data stage. So now if I run this, it will run this fairly promptly. So the same 20,000 records. Just make sure I've got those as temporary. I have got them temporary, and it run that stage in 9:45, 51 to 51. That took about 9 seconds to get through that. So that was pretty quick. But if we have the tables now in a separate run, we don't need to run that 10 seconds again. So if you've got a tracking study, it will mean that you can come off that IDF and not have to read that data every time. Now, the balance here, because I've just got some big tables, is going to be on tables. But on many other projects, you might find the balance is as much time in the data stage as the table stage. So if you've got a tracking study where you run annual tables, quarterly tables and monthly tables, you're much better only reading the data file once and then using this simple IDF equals to read the tables from it. So now if I read the tables from this, on this run, I'll get about the same run time. But of course, if I only had to run the tables again, had to add some tables, I wouldn't have to waste that 10, 15 seconds on reading the data. And if the balance was on a heavier data stage, which it will be on most projects, my project here is quite simple and quite small. If I had more variables and complex variables at that, lots of if statements, things like that, big multis also make a difference. Big multis are much heavier to process than singles. You would probably start to find the data and the table stage were about the same size, and then you would really get some benefits. So splitting it here doesn't make much difference, except of course if I had to rerun the tables, I wouldn't have to build the IDF, but I'm still quite good. I've got it down to about 40 seconds here, which is still an improvement, which means if I just want to add another table now or change something in the tables, it really is only a small part of the whole process, and I don't need to read the data. But where you've got a project that is very heavy on data stage, always split your scripts, and secondly, always try and do everything in one STP file because it avoids that problem. And the technique that people use in their STP files is if you only wanted some of these tables for a particular run, you can just set a thing here like pp run equals so that it's interactive. And for example, you could skip these tables. So you could say skip 99 on run not equal to 1. So it did those tables if you gave run a value of 1 when you ran, and then perhaps when you're doing your quarterly tables, for example, oops, I thought I copied that. So that might be they might be the tables you want for your annual tables, but then when you come to do your quarterly run where you say run is 2, you might only want to analyze it by Q1. I'm giving a rather random example here, but it would only run the tables that you wanted for that run, and everything then is in one STP file and quite tidy to work with. All right, so that's some principles and some practicalities of getting more out of MRDCL in terms of productivity when you've got perhaps tracking studies, but multiple runs or runs where you can make things temporary, or you have a tracking study where you've got different runs of tables needed. All right, so the next thing we're going to look at is where you want to pull in some data from elsewhere. Now that might be some external data you've got in a CSV file, a spreadsheet. For this example, I'm going to use a CSV file because probably more people are familiar with using CSV files than Excel files. So we haven't got to write DB loops. We can just use it as a data statement. It's a bit more limited what you can do with a data statement compared to using Excel and EPS and DB loops. But for this example, it's good enough. And so what I want you to imagine here is you've got some data that you want to merge in. This might be some coded data, some back-coded data. This particular data here is we've got 2,000 respondents and we want to pull in their hourly rate of pay. So this person here earns 22, whatever it might be, ringgit, dollars, pounds, whatever it might be, a day or an hour, sorry. So this is the hourly rate for each respondent, and we want to pull this into our survey data. And of course, it might be that you've got multiple fields here. So it might be that over here you've got an employee code where they're 1 for a senior manager, 2 for a middle manager, 3 for an employee, and so on. So you might want to pull in some other data as well. We're not going to do that today. We're going to just pull in those hourly rates because it'll be the same principle. So we have some survey data, and now we're going to merge that with. So excuse me, here's my survey data. And what I want to do is, you can see I've got the tables already prepared for me. I want to pick up that hourly pay in a variable called hourly pay, and then I want to make a variable called banded hourly pay to put them into some bands. Now, one way of doing this is to say, like I did with the data files in the first example, is to say start data, let's call it 100 this time, shall we? It's got a heading, whoops, CSV equals hourly pay.csv. So you can put the CSV on the end, it doesn't matter. Rather like the first example, I'm going to say set cells equal 100.a. So I'm going to count how many cells there are in that that spreadsheet or in that CSV file. And then I could say, rather like I did with the data files, again, DI dollar from 3, because we're starting at 3 in this CSV file, because we want to start at not at 1, not at 2. We want to say if it's respondent 1, make it 22. If it's respondent 2, make it 12, and so on. So in here we can say if $IOBS is 100.a, DI $hourly underscore pay is 100.a plus 2. Now that works absolutely fine. And if we now define a variable called banded hourly pay is $hourly pay. And I can't remember the ranges very clearly, but I'm going to do something like that. It doesn't really matter. Oops, I've managed to miss a comma there. Insert X up to 10, 11 to 20, 21 to 30, over 30 equals quote hourly pay. So that's all going to run now if I haven't made a mistake. Let's just see it in action. Let's close the CSV file and run it. Okay, I've made a mistake. 2240. If I was 100. Oh, I've said plus 2. Okay, it should be plus 1. Okay, so now it's working. And now it's doing everything you've got. And I know a lot of people generate script like this. I've seen it. We see it in support. However, I don't like that script. If we had 20 fields like that, or we had 20,000 respondents, so just imagine, let's say 10 fields, 10 fields and 20,000 respondents, that would be 200,000 if statements. That would be extremely slow to process. It won't notice here because it's quite a small project, it's only one variable, but it's a very inefficient way of using MRDCL. One of the slowest things in MRDCL is if statements. And you can see why, because when we want to set the hourly pay for respondent number 1, it has to read every line of code. It'll read that one and say, yes, I am respondent 1, that's the value I want. But it's also got to read all of these just in case there's another reference to serial number 1. And you know, and I know, that records aren't going into any of those rows there. So it has to read all those lines, even though there's nothing to process. And that will be true for every record in your sample. So this is a very inefficient way of working. And I have seen runs get incredibly slow simply because people have got all those if statements in. They're pulling in lots of data using if statements. So let's look at another way of approaching this. Let's skip round this so that we don't actually use this code at all. It's now gone. And let's look at a better way of processing it. Now, what I want to do when I process this is somewhat different. What I'm going to say is, if I go back to my spreadsheet, my methodology I'm going to use here is to say, I'm going to build a variable with each of these respondent numbers in. Now, we happen to know they're sequential. If you were sure they were sequential, you wouldn't even bother to need to read that. But let's say I don't know that. Maybe one could be missing. If I build a single variable with all those numbers, I can then assign that value to the relevant bit they are in that variable. So I can assign 22 to the first one, 12 to the second, 22 to the third, and so on. So let's see how we can do that with much more efficient. So if we say ds$resps equals $iobs, now we can build our loop. So we can say do A is 3 to cells in steps of 2, and in here we can pick it 100.a. Whoops, I need a comma, and end A. So basically that's just building me a list of all the serial numbers in a variable called resps. Let's look at it, make sure it's working. Let's shut hourly pay.csv, and it's not compiling in the tables now. My banded hourly pay is not working, so that's actually erroring at the moment because we haven't actually got the variable hourly pay written yet, and my tables are now erroring as a result of that. But you can see my variable resps is doing just what you'd expect it to. It's picking up every single number and doing what I want. Now I want to do the clever bit, which is to say $hourly pay equals $resps bracket, and now if I put in the bracket here all of those lists of values, it will assign them one-to-one to the response to the bits in the variable resps. So all I've got to do now is say do A equals 4 this time to cells in steps of 2. It's 100.a again. I don't want the last comma, end A, and a bracket comma on the end. And now I'm hoping my script works perfectly. And although this is a very small run, I assure you it would run quicker, but on a big project, you really would still see some benefits. So let's just look at that in the listing file. It's actually a lot tidier now. So you can see now I've got a list of serial numbers and a list of values. And what this is saying, for the first value in resps, assign 22, for the second 12, and this is just much more efficient code. There's no if statements in there. That will process incredibly quickly because it's just effectively making numeric, moving numerics one for one for the codes. And just to prove that the tables are working, there we go, we've got our tables out, and they look, I suspect, absolutely right. Nobody's over 30. So that's another technique that I would commend to you, and I think is really useful. And finally, we're going to look at another use of EPS where there's some shortcuts that you can do to improve your productivity. For this example, I'm not going to type it from scratch, so I'm not going to make so many errors here as I might have done if I did it as I did on the first one. What we're looking at here is a solution that's already prepared, but it gives you an intro into how you might improve it and how you can organize it so that it is easy to improve in future. So what this particular template does, it handles rating scales for me. So for example, here's question 1. Sorry, there is a number here, 1, 2, 3. Handles question 1's got a title, says that it starts in data location 11. The step is 1, so they're in data locations 11, 12, 13. The statements are in list 1, so that's for brand A, B, X, D, and E.